This video is an illustration for how to use Mathematica for calculating angles in your lab. So right here we have a 1 kilogram weight attached to a string, attached to this little nut, 2 strings, split force, and what we read is 3 newtons here and 9 newtons there. So I'm going to write it down. 3 newtons, 9 newtons. I'm going to draw these lines. And now I'm going to remove this weight. And I'm going to extend these lines. 1, 2, 3. This is 1 kilogram weight, 1 kilogram mg times 10 newtons. Our goal is to measure the angles formed by those forces. So how would I do that? Well, I need x and y axis. This is my vertical axis, so I'm going to call it A, Y. And these are my angles, alpha and beta. And I need to calculate them. And for that, I have to use first physics, second mathematics. So, of course, I need to write an equations first. For that, I need to finish my reference frame. So what I have? Force number 1, 9 newtons. Force number 2, 3 newtons. Force number 3, 10 newtons. Well, let's call them actually F1, F2, and W. Wait. And we've got y-axis. And to draw x-axis, we have to just draw perpendicular to the y-axis. Now we say that because that little nut is in equilibrium, net force acting on it must be equal to 0. Net means the sum of all forces, so F1 plus F2 plus W is equal to 0. Well, it means the sum of all components on each axis must be equal to 0. F1x plus F2x plus Wx is equal to 0. F1y plus F2y plus Wy is equal to 0. And the easiest force is W because it has only one component. We can see it from the picture. So this is my component, the X component, oh sorry, the Y component, and the X component doesn't exist, 0, and the Y component is negative, and magnitude of Y component is equal to 10, so the Y component of W is negative 10. Now, F1x, F1y. My angles are alpha and beta, so inside this triangle this is alpha. Now I can start writing F1x equals Well, it has to be negative, opposite to x-axis, and it's opposite to the angle. So hypotenuse, which is F1 times sine of alpha, which is negative 3 newtons times sine of alpha. F1y equals, well, it is positive, from triangle hypotenuse times cosine. F2y equals, well, I have to see the component before I calculate. So F2y, x, F2y. I want to start from x again. F2x. I need an angle in the triangle, beta. Alright, finally, F2x, positive because points in a positive x direction, opposite to the angle, so hypotenuse times sine of beta, or 9 times sine of beta. F2y equals positive, and it's adjacent, so hypotenuse times cosine of beta. Alright, now we can just use everything in these equations. Use means plug it in, substitute expressions, and what do we have? Negative 3 sine alpha plus 9 sine beta plus 0 equals 0. Moving on to the y components. 3 cosine alpha plus 9 cosine beta plus, it's always a plus, but the component is negative, negative 10 equals 0. And now I just want to rewrite it in a more convenient way. Negative 3 sine alpha plus 9 sine beta equals 0, and 3 cosine alpha plus 9 cosine beta equals 10. That's our system. We have two unknowns, and nowadays no one can solve these equations by hand. And hundreds of years ago the people could, but now everybody uses a computer and they forget how to do it by hand. Well, let's use a computer, an internet computer. In your manual you should have a link to this page, and if you go to equations and click on this equation, you will see a graph. Yes, that means your computer handles Mathematica. Well, now we need to test if it handles two equations, so we have to add an equation. Let's write plot 2x plus y equals 0, enter. Done. It works. You can see two red dots. Those are solutions for these two equations. What do we need to do now? We need to replace these equations with our equations. So let's refresh our equations. Negative 3 sine plus 9 sine equals 0. Negative 3 sine. Well, I don't know how to enter alpha, so I just enter x. But I did it wrong, because now it's not a sine of x, it's sin x. I need to use parentheses to indicate the variable. Now, plus 9 sine, instead of beta I write y, equals 0. That's my first equation. My second equation, 3 cosine plus 9 cosine equals 10. So 3 cosine parentheses x plus 9 cosine parentheses y equals 10. Oops, I forgot, my shift button didn't work, so parentheses are fine. Enter. Again, we have a solution. Well, they're symmetrical, so these are negatives and these are positive. Of course, we take positive. So I'm gonna round it up. It's 1.1 and 0.3. X equals 1.1, y equals 0.3. X, which is our alpha, equals 1.1. Y, which is our beta, equals 0.3. 1.1 what? 0.3 what? Well, natural computers use radians by default, so that's supposed to be radians. Radians. And now you need to convert it into degrees, and you can do it differently. And alpha is supposed to be close to 63 degrees and beta 17 degrees. And now what can we do? Measure. All we need is a protractor. I'm not sure if you can see it, but this, well, of course, a little bit off, 61, 62 degrees for alpha, and well, it's a little bit off, I have to shift it. So, well, I see 20 is pretty close to 17. And we're done, and that's how it works. And that is how to use Mathematica.